infrared eyes, scanning the black, tracking the heat, never turning back. Control 22, a covert gaze. Control 33, in the cosmic maze. Controls in the mix, secrets untold. Silent watchers, brave and bold. In the shadows, they silently glide, protecting our interest, far and wide. As Spears, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. In the silence of space, they keep their post, shields unseen yet feared the most. With precision and speed, they warn of danger, keeping us safe from the missile's anger. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. And roles in the mix, secrets untold, silent watchers, brave and bold. In the shadows, they silently glide, protecting our interest, far and wide. As Beers, sentinel of the night, watching over within.
Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Scripture, the Bhagavad Gita, Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome everybody to the stream. Happy Saturday for everyone. Hope you guys are having a good evening or morning, if you're on the other side of the world. Welcome to the first episode of the 4th different show that I'm doing, or 5th different show, however many there are now. We've got Malaysian Airlines Monday, we've got Secret Science Wednesday, we've got Free Energy Friday, and I decided to change the name for Saturday, Science and Technology Saturday, and we have the Hard Truths podcast as well. I think there's going to be a Hard Truths podcast dropping tomorrow. Hopefully I can get it edited and ready to go for tomorrow. And then I'm going to start trying to pick them up again. I'm planning on having Professor Simon Howell on next weekend as well. We're going to talk about plasma orbs and ball lightning. So we got some stuff coming down the pipe here, guys. Should be sweet. Yes, whoever reminded me, was that Dim Tillman? Thank you very much for reminding me about the other opener. I haven't played that one in so long, honestly. That one's a good one. It's a little bit shorter. So, okay, today we're going to be talking about the Casimir effect. We're going to be talking about dynamic Casimir effect, and we're going to be talking about Casimir cavities. We have a lot to get through today, and I'm going to try to do it as fast as we can. One thing I want to point out, guys, I've been reading so many scientific papers. It's actually just even mind-bending for me as well in terms of how much I've been reading. And I was reading Sakharov, who Putov had referenced with respect to the gravity being an explanation from zero-point energy, zero-point fluctuations. And apparently Sakharov is a Russian who worked on creating a hydrogen bomb for the Russians in the 50s or late 40s. And then he ended up becoming an advocate for disarmament of nuclear weapons. And so now I'm pretty much certain that the technology that we're talking about originated from the Manhattan Project. And that's when it started to take off, when we realized that not only can we split the atom, but we can extract energy directly from the zero-point energy field. And then ever since then, we've been advancing it. And I think it's just got to the point now where it's just literally like magic. And it's achieved like breakaway civilization level technology. And we've been hiding it for so long, we don't know any way to not hide it. That's my current understanding right now. With respect to where it comes from and aliens and all that, I don't know. I am going to post this paper called The Ultra-Terrestrial Hypothesis that Puthoff also wrote that I read earlier today, which is really interesting. That kind of tries to take a scientific approach to what would various scenarios of non-human intelligence look like. And one of the things that mentions is that if there was a non-human intelligence on our planet living with us, influencing our society, they may try to throw us off track by convincing us that aliens are extraterrestrial from another solar system, just so that people are confused. And I thought that was really, really interesting. Okay, so I may post something like that a little bit later tonight, guys. Hey, Cypher. Hey, my channel. Welcome, welcome. Sassy's here tonight. Ramos is here. Oh, look, we have Hermes here. Been a while, brother. Welcome to the chat. Guys, there are a lot of engineers and scientists watching as well, which I think is wild because I'm a healthcare IT consultant, but I'm out here talking about, quantum mechanics, stuff like that. The papers that we were reading today too are pretty wild. Would the plane have to land? I don't know. It's a good question. On Monday, we're going to go over some of the debris that JK Philly fan, somebody else in our Discord found an analysis of the MH370 debris. So on Monday's stream, we'll probably go over that. And spoiler alert, JK Philly fan looked through all the pieces of debris and found like at least 5 different examples where the debris seemed to have been ripped apart instead of like broken off. So it would indicate that potentially if this plane was dismantled, they like literally ripped pieces of the plane off, which does not seem consistent with necessarily the crash scenario. So pretty interesting. We'll see. Yeah, let's see who else. Anybody else in the chat before we get started here? Have I looked into Stephen Wolfram's physics project? I've heard his name, but not quite. Hey, crypto as well. Also, the reason why I didn't stream last night, guys, I had a headache all day yesterday. And then I went to get dinner with my dad, and I was just too tired after that. So that was the reason why we pushed Free Energy Friday. But we've got some great stuff here that's going to be dropping here today. If you guys saw my post about dynamic Casimir effect, we're going to take a look at that right after we talk about the Casimir effect. And then we're going to look at Garrett Moddel's Casimir Cavities design as well, which seems really similar. I'm also being, someone told me there's an APEC presentation. I didn't even know that was going on. I probably should have guessed. Also, guys, it's getting to the point where like I've learned so much already at this point, and like I'm starting to understand like what some of the secret sauce is. I want you guys to be able to figure it out yourself, but I am not going to. If I ever get to a point where I feel like I'm pushing it too much, I probably will pull back a little bit. What I will say is, if anybody gets disappointed by that, I would say that I have shown more than enough for people to figure out some of this stuff. My current opinion right now is that I've got a pretty good handle on how like a magnetic motor can produce energy. I'm 90 to 95% sure I've got gravity manipulation figured out. Now what I want to be able to do is figure out how we can extract energy using the Casimir effect without moving parts. And I want to figure out exactly how to produce high amounts of negative energy. Those are the things that I'm pretty much trying to work through right now. And I'm not going to push it all the way to the point where people could figure it out, because I literally think that it's an issue of national security and national defense. I think that these weapons that's the reason why we're hiding it. Like same with the Manhattan Project. This is why they're going to do anything to hide this. This is why the white hats and what have you that are out there too are lying about like the MH370 videos and stuff like that. Because if you get told that like this is an issue of national security and we could destroy the whole planet, even good people will lie, because for the good of the species or whatever, So Hopefully I've given you guys enough information through this that, you can help figure it out yourself. Now, the dynamic Casimir effect, you're going to notice some similarities. We may have to jump back to some other scientific papers while we're talking about that as well, guys. So I'm going to drink a sip of water, and then we're going to get started here. Yeah, okay, so we probably do need to start with something simple. Thanks for bringing this up to me, guys. So what is a battery or a capacitor? This is probably the most fundamental, important thing to understand. So anybody who tries to come at me about this stuff being fake, the first question I'm asking is, do you even know what a capacitor or a battery even is? So if we have like a battery, you have the positive side on the top. I wish I had a battery, but I don't have any. And then we have the negative side on the bottom. So how do we get charge in our dipole? So when we have the charges separated, what happens? The negative charges are trying to get to the positive charge. They're trying to equalize out. When the battery becomes fully equalized out, there's no more energy anymore. That's it. So once we achieve the symmetry where everything's been equalized out, there's no symmetry anymore. So you've got an insulator in there to prevent the electrons from getting to the positive charge. So instead, what happens is you connect it to your circuit, and now what's going to happen is the electrons are going to take the long route to try to get to the positive charge. This is how we create our circuit. This is where energy begins to flow. Now, why is that important? Because if we're thinking about how we want to be able to produce free energy, then as Tom Bearden would say or propose, is that we need to keep our dipole open. We need to make sure that the positive and negatives stay separated. I imagine the reason why we haven't produced free energy right now is the way that we're doing it right now is if you imagine a swing going back and forth. The way we're doing it is we're constantly pushing on the swing both ways. Is that efficient? No. When you're pushing a swing, how do you push the swing? Do you constantly push it back and forth? No, you don't. You don't want to work against the swing coming back at you, right? So you don't push the swing when the swing's at its highest point in front of you either. That's the worst time to push it. What you want to do is you want to wait for the swing to come back, and then you want to push it and give it a shove. So we want to come up with a way where we can keep a dipole open, where we can give it a little bit of shove here and there. This is the secret, in my opinion, to free energy. I think, at least with respect to a device that has no moving parts. And you're going to find there's a lot of connections between all the science we've been talking about: free energy, negative energy, wormholes, warp drives. The secret is the Casimir effect. So what is the Casimir effect? So now that you guys understand a battery or a dipole, it's Ryan just realized he's been pushing the swing the wrong way this whole time, chat. The whole time. It's funny because I told my mom that analogy. I wanted to test it on her, and she goes, "Oh, even I can understand this now." And the key is, obviously that's not an accurate representation for really a dipole, but what's happening is when we're burning fuel or whatever, what we're doing is we're keeping our dipole open. We're using that to separate our charges, and then that way the power continuously flows out. So when you simplify that, then what does that mean? That means that as long as our dipole is open, as long as our charges are asymmetrical and separated, power is flowing. Power is flowing. When you look at it through that lens, that's where you get to where Tom Bearden says, let's go ahead and pull it up, that all the fuel in the world has not added a single watt to the grid or to the power lines. It's the dipole being open that's allowing it to happen. So I'm going to pull that up real quick. Watch a little bit of video here. I wish I actually had a video for the Casimir effect, but I don't think I do. So here we go. StreamYard's so annoying.
We thought the generator powered the external circuit. It doesn't. It does not power it at all. All it does is we twist the crank on the generator, the shaft, to turn the shaft, and that forms a magnetic field inside the generator. And that energy in that magnetic field dissipates itself upon the internal charges to force the positive charges in one direction and negative charges in the other to make that dipole. And that's all a generator does. It doesn't add 1 watt to the power line. all the coal, all the oil, all the dams ever built, all the nuclear fuel rods ever consumed, never added 1 single watt to the power line. All they did was keep rebuilding the dipole that we have designed the silly circuit to destroy faster than we can power the loads. We thought the generator powered the external circuit. It doesn't. It does not power it at all. All it does is we twist the crank on the generator, the shaft, to turn the shaft, and that forms a magnetic field inside the generator, and that energy in that magnetic field dissipates itself upon the internal charges to force the positive charges in one direction and negative charges in the other to make that.
Okay, I just did that twice. Okay. But yeah, that's the part that's important, is that it's basically the generator is just pulling the charges apart, and it's making the dipole stay open. So this is also kind of what I think Deadly Storm here says: electromagnetic fields that switch position to push at the proper moment. It's actually pretty simple. It really is. And a lot of this physics, what you find out, is part of the reason why I'm like holding back a little bit isn't because I'm trying to be coy about it and be like, oh, I know the secret and no one else does. It's because it's actually really simple when you boil it down. It's not this like complex, you got to do super complicated differential equations, though for the math you kind of do, but to understand it conceptually, you generally don't. A lot of this stuff is much simpler than what people imagine. Whether it be gravity manipulation and free energy, or understanding energy in general. I mean, when you think about it like the way we just described it, isn't it kind of straightforward? That's why, like, when this is another thing real quick as a side note, I was talking to my parents yesterday about when I was in high school and what have you. They call it International Baccalaureate Higher Level Physics. And I never liked physics because I always felt like there was something missing. And part of the reason why I'm so passionate about this is when I started digging into those videos and the science behind them, and went, holy crap, this answers all the questions that I didn't like intuitively understand before. This is why I didn't intuitively understand them before, is that it was so much more simple than it was being made out to be. And all the things where we're saying we don't know, like, we can figure it out pretty straightforward. So the other thing I would say is that a magnet is also a dipole. And the benefit of a magnet is the way that we know we can manipulate the magnet is the magnet doesn't run out. The dipole never equalizes. It stays asymmetrical. That's the beauty of the magnet. You have your North Pole and you have your South Pole. And those magnetic lines, years and years can go by, and you're going to still have your magnet. So you can imagine if you can use the magnet to manipulate the dipole to keep the charges separated using either some type of time, what's the word I'm looking for here? Like a timed pulse that's timed specifically to a specific resonance, then maybe that's the answer. And this is why magnets, to me, are definitely the key to free energy. If you want to be able to produce free energy, I think you pretty much have to have magnets no matter what you're trying to do. And then how you configure them to keep that dipole open, that electric dipole, pretty interesting. There's also something else that we're not going to talk about today, but I'll give you guys a quick little spoiler on. Something called where is it? Electret. And an electret is like a metamaterial that seems to have like a static electric field that doesn't break down as quickly. So I'm going to look into that because I'm wondering if there's something where you can create some type of metamaterial that also has similar functionality to what we're looking for. I don't know what rock gate is. Sorry, I'm not familiar with all this stuff. I'm still learning a lot, guys, so I don't know everybody. Okay. Yep. I don't know what this link says, but if somebody can find out what that link says, I'd be very curious and put it in our Discord. Okay. Now let's take a look at Casimir effect here. Okay, I've got a couple things here for Casimir effect. Which one's the simple one? Well, they're both kind of long. So I don't know. We'll just do a quick brief look at both of them here. Okay. So Casimir effect. What is the Casimir effect for people who are new or they don't know, they haven't been watching or whatever? So Casimir effect is actually pretty simple. Casimir is the one who figured it out back in, what, the 40s or something like that, maybe earlier. Actually, it probably says somewhere in one of these documents that we'll see. But the basic idea is pretty simple. It proves that there is this vacuum energy. And the way that it proves that is you put two conductive plates very, very close together. And what will happen is they will squeeze together. And the reason why this is happening is because certain wavelengths cannot fit between the plates. And so if less wavelengths are able to fit between the plates and more of them on the outside, you're going to have this pressure. You could argue that that's what gravity is, honestly. In fact, I think that is what gravity is. So if we have this Casimir effect, and if you guys watched our stream last week for Free Energy Friday last week, you will see that in the Puthoff paper, the Puthoff and Eric Davis paper on extracting energy from the vacuum, and I think it may be actually one of the DIRDs where they talk about it. There's actually, both of them are like they borrow from one another. It even mentions that this is proof that we can extract energy from the vacuum. The issue is that it's not perpetual, that you have to pull it apart. And this is why when you see me arguing with some of these other physicists and what have you, they're always, I don't want to say it's dishonest, but it's ignorant, is that they intentionally frame the argument in a disingenuous way where they say, well, yes, you can, extract energy, but it's not really extracting energy because you have to pull the plates apart. But we don't have to pull the plates apart. If we had a bunch of plates all next to each other, then we could extract energy from each one and then throw the plates away. So I forget what the guy's name was, but he was objectively wrong. He never apologized for being wrong. Rarely, these guys are so egotistical, these physicists and stuff, these mainstream normie brain people, they never apologize for being wrong, but he's objectively wrong. You definitely can extract energy. The only issue is, can it be perpetually extracted? So it can't be perpetually extracted using two plates. But so what? Now that we know it's possible, now it's an engineering challenge. How do we engineer our experiments so that we don't have to use two plates that we have to pull together? We need some kind of situation where we can have the plates automatically pull apart or have an analog, an analogy to the plates pulling apart. Hey, Gerald, welcome. Welcome, buddy. Appreciate you. And this is the reason why it's so important. The Casimir effect is so important in all of this. Casimir effect shows that we can extract energy, and it shows a negative energy pressure differential. Now, when we talk about warp drives, when we talk about wormholes, we need negative energy. And we don't even understand what this concept of negative energy is. My current understanding is that negative energy is like removing all of the electromagnetic fluctuations in a certain area. If there's this latent energy that's always out there, you want to remove that. And if you remove that, you can imagine this is the zero point. If we can go below this and remove all that energy in a certain area, now you're going to have that negative energy pressure differential. Scoop on in. So this is why Puthoff and Davis have, in the wormhole papers, they have speculated you need to create a Casimir cavity or a Casimir shell. So actually, real quick, I think I want to show the Puthoff video because he says this specifically, just so you guys know what I'm talking about.
That has to do with this background fluctuation.
That's right, changing the density.
I think he says it in this one.
You say changing the polarizability of the vacuum is another way of looking at it.
So you're accelerating through the vacuum, right? Because when you say you're accelerating within this quantum fluctuation, it has an effect on that background field.
That is certainly the case, because it's essentially pushing aside the vacuum fluctuation to some degree, and that's what's causing.
You just hear what he just said right there? It's essentially pushing aside the vacuum fluctuation. This is like 20 years ago. I don't even know how old this is, but this is way before HD. Listen to that one more time, what he just says right there.
That is certainly the case, because it's essentially pushing aside the vacuum fluctuation to some degree, and that's what's causing the resistance.
Because the vacuum fluctuations are what's causing the resistance. When we move around, what is inertia? Inertia is us flowing through the vacuum fluctuations that are out there. So if you pull away the vacuum fluctuations, what happens? You're going to go flying. Well, that's what the same effect that we would expect from negative energy or negative mass. So at the end of the day, then pulling aside the vacuum fluctuations is negative energy. So negative energy then isn't some exotic substance. It's just regular energy. It's just getting rid of going below the baseline equilibrium of the energy levels that are all around us all the time. This is important because when we're trying to engineer a solution, we need to know what the problem is. I'm going to listen to it one more time for people who weren't paying attention.
That is certainly the case, because it's essentially pushing aside the vacuum fluctuation to some degree, and that's what's causing the resistance we call inertia.
But how would you actually contract space-time to do that? I mean, what effect could you put out there to have that?
Well, we know from switching over the general relativity side of it that you can look at the equations, whether you're using standard general relativity or some of the other approaches to general relativistic type effects, and very strong fields, strong masses. I mean, the mass of the Earth affects the space around it, which, thinking in terms of zero-point energy, is affecting the distribution of zero-point energy.
So if you go to that equation, F equals ma, where the mass times the acceleration equals to 4.
Putup's like, yeah, I know about F equals ma.
If you create a force, you can generate a mass that would have an effect on space.
We might generate a force that would move a mass, start to accelerate it. Or, I mean, what you'd really like to do is just scoop out the energy in front of us, and the energy behind us would just shoot us forward. So,
and that's possible. That's not just a Star Trek.
So scoop out the energy in front of us, and what will happen? The energy behind us will push us forward. Why is it going to do that? It's going to do that because we've created a negative energy pressure zone in front of us. And this is also important because the way that he phrases it here, I think that Alcubierre might have gotten it wrong a little bit. We don't need to remove energy in front of us and add energy behind us. If we just remove energy in front of us, we're going to go forward. Why is this important? Because that's what the orbs are doing in the MH370 videos. I don't think the orbs are actually creating an Alcubierre warp drive, but it's the same exact engineering metric of the vacuum, is that they're simply devoiding the energy in front of them. The negative energy laser is simply removing the energy in front of us, and they're just falling through it like a well. This is why Salvatore Paez was so excited to talk to me because his high frequency gravitational wave generator is basically this device. That's exactly what you'd be looking for. And I can't go too much more onto that just because it's probably pushing the limit there, but that's what I want you guys to be imagining. So keep in mind, how do you remove all the energy in an area? That's what we want to be thinking about. How do we remove all the energy there? How do we remove all the wavelengths, all the electromagnetic fields inside of any region of whatever size that we want?
Concept, but you've seen.
we know, I mean, small effects, all of general relativity, for example, is based on these principles. And we can calculate, well, gee, if only we had so much energy.
Right.
And then we can make this big effect, we could power a spaceship and so on. It's just that we don't have the engineering tools to do it right now. And frankly, those of us who are working on it think there's still something missing in the theory because it's so hard to do. We don't see that it could ever really be done. And yet, maybe there's some evidence that there are spaceships out there that don't belong to us, belong to somebody else. Well, in that case, they must have gotten around it. So there may be some unexpected factor that could suddenly cause a resonance to occur where with a lot less energy, you can get a big effect.
So that's interesting as well, because he actually mentions that maybe there's a way to get a big effect with a lot less energy than what we're thinking. I think he's being coy here. I think he already knows when he made that video. I think that Hal Puthoff is a very, very smart guy, and I think he's very careful about what he puts out there. So here's the part about the wormhole.
Open up a time-space and slip into another part of the universe.
Right.
That's a possibility.
Yeah, general relativity, if the equations are right, that's a possibility.
And how does that actually work? I mean, how can you actually, what do you need to do that, to open a wormhole in basic layman understanding?
You need
This is the part where he's going to mention the Casimir wall. Get ready.
a lot of energy.
Yeah.
That's one thing you need. You need to structure it in a certain way so as to affect the vacuum. we can write the equations for it, see how it is. It's a little hard to describe physically. I mean, actually, we don't really know how to actually go out and do it physically, because there are few little things like, well, I'm going to need some negative energy here. Where am I going to get some negative energy?
Hold on, gotta play it. Where am I going to get some negative energy?
All right, then, keep your secret.
Well, in some sense, the Casimir effect is actually considered a negative energy thing. So, okay, maybe I want to have Casimir walls around my wormhole. And
Okay, so right there, chat. What if I make Casimir walls around my wormhole? Okay, you have my attention, good sir. You have my attention. And yes, I think he's being coy. Also, hey, Matt Reynolds, nice to see you. Dom, one for Nate. $10 donation. Thank you very much, brother. I really appreciate it. I also need to shout out a couple people. James, thank you very much for donating Thursday. Appreciate it. Also, Leaf, I hope this wasn't an accidental donation. It's kind of a weird one, but this is a huge $111 donation and 11 cents. I don't understand the message that was sent with it, so hopefully it was for me and not for somebody else, but thank you very much. Those are some huge donations, guys. James with $25 donation as well. Thank you guys very much. Those were on the Cash app through Twitter. Really nice of you guys, man. Appreciate it. Okay. So I'm going to replay that part about the Casimir wall one more time. Because where do we get negative energy?
Because there are few little things like, well, I'm going to need some negative energy here. Where am I going to get some negative energy? Well, in some sense, the Casimir effect is actually considered a negative energy thing. So, okay, maybe I want to have Casimir walls around my wormhole. And so we see the mathematics of it can predict that if general relativity is right. I mean, this is enough to make some people say, general relativity must be wrong if it predicts that. And there are some other models that, more or less match general relativistic.
If we have a Casimir wall, and the part he says right there, I like as well at the end, where he says this makes some people think that maybe general relativity is wrong because it's so weird. Is that general relativity, Einstein's equations say that we can bend space-time, and bending space bends time, and we can actually make a wormhole. It's a literal mathematical solution to Einstein's general relativity. And this is where people then go like, "Ugh, that's weird." Is that, can general relativity be correct if it says that we can make a wormhole? General relativity is correct, I think. And so this is where, I think that the mainstream physicists, where they struggle with the concept that we can do some of this because it seems so magical. But that's what space-time is. It's magical. And even stuff like time dilation shows us that, general relativity holds up. Okay. And I think there's more than one way to accomplish the negative energy in general, but the Casimir effect is a very interesting one. So let's go back to this Casimir effect paper, or this is just like a news article. Oh, what? That's not it. Here, I'm going to show it like this. What happens if you take two mirrors and arrange them so they're facing each other in empty space? Your first reaction may be nothing at all. In fact, both mirrors are mutually attracted to each other by a simple presence of the vacuum. This startling phenomenon was first predicted in 1948 by the Dutch theoretical physicist Hendrik Casimir, while he was working on the Philips Research Laboratories in Eindhoven, of all things, on colloidal solutions. The phenomenon is now dubbed the Casimir effect, while the force between the mirrors is known as the Casimir force. So when we're talking about a mirror, generally they're talking about a perfectly conductive surface. And in recent years, they were able to show that you don't need to necessarily have a perfectly conductive surface to be able to pull it off either. Some people have speculated, in fact, that if you use certain metamaterials or certain materials, that you can actually change the properties of the effect so that even it could repulse instead of pulling together. Pretty interesting. Okay, so let's say, although the Casimir force is completely counterintuitive, it is actually well understood. In the days of classical mechanics, the idea of the vacuum was simple. The vacuum was what remained if you emptied out a container of all of its particles and lowered the temperature to absolute zero. The arrival of quantum mechanics, however, has completely changed our notion of the vacuum. All fields, in particular electromagnetic fields, have fluctuations. In other words, at any given moment, their actual value varies around a constant. mean value. Even a perfect vacuum at absolute zero has fluctuating fields known as the vacuum fluctuations. These are the 0-point fluctuations. The meaning of energy, the mean energy of which corresponds to half the energy of a photon. However, the vacuum fluctuations are not some abstraction of a physicist's mind. They have an observable consequences that can be directly visualized in experiments on a microscopic scale. For example, an atom in an excited state will not remain there indefinitely long, but will return to its grounded state by simultaneously or spontaneously emitting a photon. This phenomenon is a consequence of the vacuum fluctuations. Imagine holding a pencil upright on the end of your finger. It will stay there if your hand is perfectly stable and nothing perturbs the equilibrium, but the slightest perturbation will make the pencil fall in more or less a stable equilibrium position. Similarly, the vacuum fluctuations cause an excited atom to fall to its grounded state. Okay. While the Casimir force is too small to be observed for mirrors that are several meters apart, it can be measured if the mirrors are within microns of each other. For example, two mirrors with an area of 1 centimeter separated by distance of millimeter or something? I forget. Have an attractive Casimir force of about 10 to the minus 7. Roughly the weight of a water droplet that is 0.5 millimeter in diameter. Although this force may appear to be small, at distances below a micrometer, the Casimir force becomes the strongest force between two neutral objects. Indeed, separations of 10 nanometers, about 100 times the size of an atom, the Casimir force produces the equivalent of 1 atmosphere of pressure. So even though this force is weak at long distances, the closer they get together, this force becomes extremely powerful, which is why it has a relationship to the van der Waals force. The van der Waals force would say that it's the force between two subatomic particles becomes very powerful. And now this is where we can start to realize that there's an association or connection between gravity and electrostatics. In fact, they may be one and the same thing. What did Veritable Genius say? We need to figure out transition to a new tech reality without creating a socioeconomic collapse. Yeah, you're starting to get a little bit bigger in terms of the thoughts, but yes, you're right. Okay. Let's go to... Actually, I think that's probably good enough for this one. And I think then they talk about like using a pendulum and some other like advances that they took to the Casimir effect. Now this one is another longer explanation, but I think there was some parts on here that I wanted to take a look at. Oh yeah, here we go. Actually, we may just skip this. Okay, attractive and repulsive forces are not the only two kinds of forces produced by the Casimir effect. In the 1970s, researchers realized that when the materials that make up the plates were optically anisotropic, they would generate a torque with respect to each other. That's because the total free energy, which normally depends on the separation between the two parallel plates, also depends on the angle that defines their relative orientation. The conceptually obvious way to demonstrate the effect would be to rotate two birefringent crystals relative to each other and measure the torque as a function of the distance between the crystals. But the difficulty of keeping two large parallel plates complicates the measurement, as does the presence of dust and the surface roughness. Monday's group attacked the problem more cleverly by replacing one of the bifringe plates with a liquid crystal. Okay, well, some of this stuff's going to be a little too complicated for me. Oh, here we go. Okay, no, we do want to read this. Those experimental and theoretical results are more than just demonstrations. They point to a future work in which the Casimir force can be used to manipulate nanoscale objects. In MEMS devices, high surface-to-volume ratios often result in unwanted stiction that could be mitigated with a repulsive Casimir interaction. What's more, by producing attractive and repulsive forces and torque at the nanoscale, one can create, at least conceptually, a motor tractor beam for moving quantum dots, nanowires, bacteria, viruses, and other minuscule objects. In the dynamic Casimir effect, DCE, photons are created by a rapid change in a system parameter, such as an electromagnetic boundary condition. For example, a mirror in an optical cavity moving at a rapidly at a frequency f generates pairs of photons with frequency f divided by 2 from the vacuum. Moving a mirror at relativistic speeds is no mean feat, and researchers have relied on changing another system parameter, such as the index of refraction, instead. The effect has been seen in superconducting circuits, a Josephson metamaterial, a Bose-Einstein condensate, and photonic crystal fibers. Now that you probably want to be paying attention to. How is this related to the static Casimir effect? Imagine a mirror moving slowly. The quantum fluctuations can easily keep up with the mirror and their energy stored in the modes of a cavity. Cavity is just an area. Can give rise to an attractive or repulsive forces. If the mirror is accelerated to relativistic speed, the virtual photons that pop into existence get separated from their partners and produce real photon pairs. The dynamic analog is a way to essentially mine the fluctuations by stripping photons from the pairs. In the static Casimir effect, the fluctuation produce a force. In the DCE, dynamic Casimir effect, they produce photons. So that's sweet as hell, guys. So what's going on right there? Imagine this. Okay, so you've got mirrors here, and you've got something moving at the speed of light, photons moving at the speed of light. Let's say it's resonating back and forth at the speed of light. So you've got two mirrors, so it's just bouncing back and forth. What if the mirrors are moving so fast that it's actually some proportion to the speed of light itself? So fast that by the time this photon bounces off this mirror, now the mirror's on the other side. When it hits the back of that, now it's in the same mirror again. If you're actually doing this, it seems like this is a way where you can literally just extract photons from the vacuum, something from nothing. You can take those virtual photons, you can turn them into real usable photons. That to me is very exciting, and that's what the dynamic Casimir effect shows. So that's going to get into our next paper here. Just want to see if we want to look at this. We might come back to this, but I think now we're going to switch over to the Casimir effect paper. Okay. So now, observation of the dynamical Casimir effect in a superconducting circuit. Very nice. Oh, sorry. Is there... hey, Billy, nice to see you, brother. For some reason, some of these comments are getting messed up in my list here. Okay, so one of the most surprising predictions of modern quantum theory is that the vacuum of space is not empty. In fact, quantum theory predicts that with teams with virtual particles flitting in and out of existence. While initially a curiosity, it was quickly realized that these vacuum fluctuations have measurable consequences. For instance, producing a Lamb shift of the atomic spectrum and modifying the magnetic moment of the electron. This type of renormalization due to the vacuum fluctuations is now central to our understanding of nature. However, these effects provide indirect evidence for the existence of quantum fluctuations. From early on, it was discussed if it might be possible to more directly observe the virtual particles that compose the quantum vacuum. 40 years ago, Moore suggested a mirror undergoing relativistic motion could convert virtual photons into direct observable real photons. This effect was later named the dynamical Casimir effect. Using a superconducting circuit, we have observed the DCE for the first time. The circuit consists of a coplanar transmission line with an electrical length that can be charged at a few percent of the speed of light. The length is changed by modulating the inductance of a superconducting quantum interference device, SQUID. That's what they call it, superconducting quantum interference device, SQUID, at high frequency. In addition to observing the creation of real photons, we observe a two-mode squeezing of emitted radiation, which is the signature of the quantum character of the generation process. So I'll pull this up real quick so you can take a look. So this paper is pretty big. Shout out to Andrew Cote. I don't know how you say his last name. But he got excited when he saw this. I direct messaged him a little bit because I knew he knew about superconductors. And whenever I see superconductors, I get really excited because the things that keep coming up time and time and time again, Casimir effect, superconductors. So definitely seems really important. Okay. The part that I want to look at here. Sorry, I'm trying to remember which part. Okay, so basically they say, oh, where's the part where 1 divided by v? Okay, right here. If we consider a literal experiment of moving a physical mirror near the speed of light, we quickly see that the experiment is not feasible. So trying to move the mirror at the speed we need to is not feasible. So we need another way to do it. So Bragio et al. Considered the case of moving a typical microwave mirror in an oscillating motion at a frequency of 2 gigahertz with a displacement of 1 nanometer. This produced a velocity ratio of only 10 to the minus 7. It's very, very, very small, with an expected photon production of approximately just 1 per day. That's very little. We need something much higher than that. Nevertheless, it requires an input mechanical power of 100 megawatts, while at the same time, the system would need to be cooled to 20 microkelvins, so basically absolute zero, to ensure that the electromagnetic field is in its vacuum state. These difficulties have led to a number of alternative proposals, for instance, utilizing surface acoustic waves, nanomechanical resonators, or by modulating the electrical properties of the cavities. Here we investigate one such proposal using a superconducting circuit, basically the squid. At the frequencies studied here, the squid acts as a parameter inductor whose values can be tuned by applying a magnetic flux through the squid loop. When placed at the end of the transmission line, this squid can then be used to change the line's boundary condition. As it said before, we need to change the boundary conditions. That's the same as having our mirrors rotate around. In previous work, it would show that this tuning can be done on very short timescales. The change in inductance can be described as a change in the electrical length of the transmission line, and in fact, provides the same time-dependent boundary condition as the idealized moving mirror. So basically, this is just replacing your moving mirror. In the same way as for the mirror, the boundary condition is enforced by screening currents that flow through the squid. Unlike the mirror, the effective velocity of the boundary defines the rate of change of the electrical length, and it can be very large, approaching 0.05. So compare the two numbers. Up here, it was 10 to the minus 7. That means there's 7 zeros before the 10. Here, there's just 1 0 before the 5. So this is like, how many magnitudes? 6 orders of magnitudes more powerful for a 10% modulation of the squid inductance. The photon production rate is therefore predicted to be several orders of magnitude larger than other systems. So right here, we're not talking about amplification. We're talking, this is a whole new scale of being able to produce photons. The old one was producing 1 photon per day. I don't know how many photons this would produce, but a shitload compared to that. Shitload. Okay. I don't know enough about lamb shift, but I'm going to have to look into that for sure as well. Okay. Now, this is the other part that I wanted to read. So it's really just the next part. Quantum theory allows us to make more detailed predictions than just photons that will simply be produced. If the boundary is driven sinusoidally at an angular frequency of WD equals 2 pi f to the d, F, I think, is frequency, W, I'm not sure, then it is predicted that photons will be produced in pairs such that their frequencies, that's the frequency, sum to the drive frequency, i.e. we expect WD equals W1 plus W2. Oh, interesting. Huh. This pairwise production implies that the electromagnetic fields at these frequencies, symmetric around the frequency, the drive frequency divided by 2, should be correlated. In detail, we can predict that the field should exhibit what is known as a 2-mode squeezing. These correlations are a signature of the 2-photon nature of the photon generation process. Okay, guys, I got to switch to another video right now because right now I can't stop thinking about the MH370 video. Why? Because look at this video. Is that what's happening here? These orbs are moving around the plane in a sinusoidal pattern. If they're graphed out, they're moving in a sinusoidal pattern. And this is basically saying that if you move them in a sinusoidal pattern, then the drive frequency is the combination of the individual frequencies. And is this squeezing the vacuum exactly the way on a macroscopic scale? Is that what this is? Also, it's literally impossible for this video to be fake. Just unless a PhD physicist with a understanding of quantum mechanics made this video somehow, then the video has to be real. The science is too accurate to quantum mechanics. There's no random student accidentally made videos with orbs moving in quantum dynamic Casimir effect quantum mechanical way. Just no chance. So look at the orbs, the way they're spinning right here. And then when they start to converge, this is where, I think it's a combination of the Casimir effect and Coulomb's law in terms of the squeezing effect that they're applying on the vacuum state. So in my opinion, there's no doubt they're engineering the vacuum right here around the plane. And I think this paper explains it. Because if you're making a Casimir, some type of cavity or a Casimir wall, then isn't that what this looks like they're doing? They're making a Casimir wall around this plane. It's not even an issue of editing software or any of that other stuff. It's just literally a matter of the science is too complex for this to be fake. You can ignore everything else. You can ignore all aspects of, how much visual effects expertise you'd have. There's not enough people on the entire planet that know how this science works. There's not even enough on the entire planet. And the number of them that are actual VFX experts that come up with this, zero. Just zero. Certainly not some student that did this in their backyard in 2 hours or whatever bullshit these morons keep posting. No fucking chance at all. 0.0% chance. This is definitely some type of super weapon that we are hiding from the world, based on Casimir effects. And then I'm going to one other thing I want to show real quick is I want to show the squeezing part here again. Because right here now, we have a much better idea of what's going on right here. So what we're seeing right here is we're seeing this squeezing effect of the vacuum. So somehow they're creating some type of Casimir wall around the plane. And then that's able to produce, I don't even know if you have to produce like a thick wall, like just a shell. A thin shell of a Casimir cavity can probably displace whatever's inside of it. And then that's how you get around the energy requirements. When Puthoff says you only need a little bit of negative energy, and you can use something like the dynamic Casimir effects, like look at how they squeeze in like that. That's how they're able to do that. And they just have to keep it open long enough for the plane to go through it. And then relativistically, the plane's going to appear instantly on the other side. I would love to see the other side of this. I would love to see what happens on the other side. I bet it's fucking crazy. Anyway, okay, let's go back. Okay. Okay, the rest of this is a lot of math here and the boundary conditions, and they show some equations, and here's a circuit as well if you want to see it in terms of how it works. My engineering is not quite up to par enough to be able to explain the circuits and stuff for you guys. Yeah, just for the record, there's 0% chance those videos are fake. Literally 0%. If any of making those videos was easy, then there'd already be a dozen people who have remade the videos. You can literally just copy the existing videos. Nobody's even come remotely close to making the videos. Nobody at all has even been able to make the orbs look even remotely realistic compared to the original, like not even remotely. Even on the best satellite video recreation where they just copied like everything they could possibly copy, they can't even get the orb to come flying in correctly. The very first orb that comes in, they can't even recreate that, let alone everything else. Because it's very, very, very difficult to recreate real relativistic motion accurately, scaled down. Extremely difficult. A lot of people really, really, really overestimate their abilities. At the end of the day, it's a year later, and nobody was able to recreate those videos. Nobody, not even the Corridor crew could recreate them. Corridor crew couldn't even recreate 5 seconds of the drone video. They couldn't even recreate 1 second of the drone video. That should give you some ideas that a major YouTube studio with like 6 million followers couldn't even recreate 1 second of the drone video, even with something to copy. So sorry to burst your bubble, guys. And oh, by the way, the people that hoaxed the video would have had less than 72 days maximum to make the videos. That's the maximum amount if they started the very moment the plane disappeared. No chance, brothers. No chance. I mean, it's cool if people want to believe in that, you know, somehow those videos are fake. I really don't care, but I wouldn't be teaching quantum mechanics right now if those videos were fake. Look at it like that. I wouldn't be teaching real quantum mechanics if those videos were fake. Okay, so this goes in the math. You guys can check out some of that if you want. I posted a link to the paper on my Twitter channel. I'm just going to go to the last part here. It says, in conclusion, we observe broadband generation of microwave photons in an open transmission line with a periodically modulated boundary condition. The emitted photons exhibit two-mode squeezing correlations, which are characteristic of photons generated in correlated pairs. Taken together, we believe these results represent the first experimental observation of the dynamic Casimir effect. Why is this so exciting? This is so exciting for two reasons. One, it shows that the Casimir effect can be engineered. Second, it shows that we can extract something straight out of nothing. And it shows that there must be energy in the vacuum. So this, to me, proves the ether is real. The ether is real. There's energy out there. We can extract it. They're talking about literally just pulling photons out of nowhere with this paper. And then the question is, well, can we use stuff like cold fusion to produce elements out of nowhere? Or can we engineer this a step further to be able to produce elements, like literally just here's hydrogen out of nowhere? I think the answer is yes. I think that's probably well beyond what we have in the public science right now, but I think it's absolutely possible. We'll see. Okay, now I want to switch over and I want to go to a video. This video is Garrett Moddel, and this is him talking about his Casimir cavities. Now, if you look at the design of the dynamic Casimir effect compared to Garrett Moddel's Casimir cavities patent, very similar. He used a semiconducting plate, an insulator, and another semiconducting plate. And then he has a cavity above that. And the idea is that you're going to trap your electrons to create an energy differential, a pressure differential. At least that's my understanding. But we're going to hear it from his own words, and we're going to hear it from him. The reason why I love this is I want something that's solid state, that can be miniaturized, that we can use to extract energy or to create a negative energy effect, because all this stuff is connected. We can then use that. We can engineer it to produce energy from the vacuum indefinitely, or we can use it to, make a negative energy type effect, laser weapon, whatever the hell we want to call it. Also, one more thing. Where's my other paper? Shit. Where's the one by Forward I had? Shit. Well, there's another paper. Oh, here it is. Okay, I found it. Okay, now I asked some people about this paper here. Apparent endless extraction of the energy from the vacuum by cyclical manipulation of Casimir cavity dimensions. This is by Robert Forward. Now, Forward is the one who everybody's been referencing in the extraction of energy using the Casimir effect. So this is who Eric Davis, Hal Puthoff, basically everybody has been mentioning this idea of what Forward had speculated. Now, I talked to some people about this because I was like, well, how is this not it? Apparently, there was some, like, this caused a big stir when this paper was published. I think it was like 1999 or 2000, somewhere in that range, maybe 2001. And some people did some formal responses to claim that it was conserving energy, so that this was technically not extracting energy. And then I think that part of the reason why people have built on it is because, maybe there's ways around those refutations of this. But this is part of the reason why I haven't promoted this as the absolute solution to what we've been looking for. Because, I mean, you look at the header here, and it's basically, boom, there it is. This is on the NASA website, by the way, guys. So I'm just going to read the abstract, and then we're going to go back to Garrett Moddel, because this is what Moddel is trying to do. He's trying to use Casimir cavities for cyclical manipulation and extraction of energy of the vacuum. So it seems like Moddel saw this and then was like, oh, I'm going to try to see if I can figure this out. What was he said? Old laser printers have good mirrors in them, huh? Maybe. I think you can't use mirrors for this because you can't increase the speed high enough to be a significant percentage of the speed of light. It takes too much energy. The other thing you notice from the other paper is that you have to cool the semiconductors or the superconductors or semiconductors, whatever. And it takes a lot of energy to cool them as well. This is why room temperature superconductor metamaterials will change the game as well. Because if you get rid of that energy requirement, now you can really start to break stuff. So this is part of the reason why, in my opinion, they're definitely suppressing like LK99 and other room temperature superconductor metamaterials, because it'll allow us to just be able to engineer crazy stuff without the need for a lot of the excess energy that we have to put in. Okay. The abstract here is in 1893, Ambijorn and Wolfram produced plots of energy density of the quantum mechanical electromagnetic fluctuations in a volume of vacuum bounded by perfectly conducting walls. So you can imagine a mirror or a superconductor in the shape of a rectangular cavity of dimensions A1, A2, and A3 as a function of the ratios of A2 divided by A1 and A3 divided by A1. So I think basically saying the square, if I'm correct. Portions of these plots are double valued in that they allow rectangular cavities with the same value of A2 divided by A1, but different values of A3 divided by A1 to have the same total energy. Using these double valued regions of the plots, I show that it is possible to define a Casimir vacuum energy extraction cycle, which apparently would allow for endless extraction of energy from the vacuum in a Casimir cavity by cyclic manipulation of the Casimir cavity dimensions. So I guess I think what he was trying to say here is you actually make a rectangle and then you manipulate, you have your rectangle like change like this. And that theoretically would allow for constant extraction. But I think then some people came in and said, no, this is still going to conserve momentum or conserve energy. So therefore you're not getting excess energy out of it. But if there's ways around that, then maybe there's something there, guys. Maybe there's something there. Okay. Man, why is my thing? Okay. So let's listen to my boy here. It's my boy Blue. Garrett Moddel. He's going to describe it in his own words here. And by the way, Garrett Moddel, he's a PhD physicist. He's a professor. I forget where he's a professor at. Professor emeritus of photonics and quantum engineering at University of Colorado. So basically, we're now on the level of quantum mechanics PhD professors at this point, chat.
We're going to be talking about 0-point energy, and I know it's a phrase that is commonly heard.
While I'm going to let this play for a second, hopefully I don't get whatever the YouTube shit does to me. I'm going to make a quick martini, but I'm still listening in here as well. Oh, what Ernie says something. I started out as an engineer in electrical, electronics, and mechanical engineering. We can do it. Laser mirrors, crystal filters, electric capacitor walls, filters, and store energy, cool energy. NASA, yes. Yeah, there's other ways to pull it off for sure. And there's also like when we were reading before about like crystals and stuff like that, I just haven't gotten to that part yet, guys. So truth is, I don't claim to be any kind of expert. I'm just trying to catch up as much as I can. I read 3 scientific papers today. That's about the most I can do in one day. We'll see. Okay. I guarantee there's ways to pull this off, though. Really, what I want to do is I want to inspire the audience here, everybody who's listening, and people who are watching this later on, for you guys to figure out like ways to break it. You know, so I often talk about the magic cards back here, and in magic cards, you're not just trying to make a good deck. A good deck is great in magic cards. You know, you make a good deck and you win, 55% of your games. That's considered good. When you make a deck that breaks the system, breaks the rules, that wins on a dimension that other people aren't even playing on, that's where you start to get like win rates of like 75, 80%. That's what we're looking for. We're looking for the deck that breaks the rules. And there's definitely ways to pull it off. There's probably more than one way to pull it off. So I want you guys to be imaginative, use this information about Casimir and 0 point energy, and I want you guys to be the next Teslas of the world and geniuses that are out there. I don't want to live in a fucking world where we got to live with this bullshit that we deal with every day. I want to live in Star Trek world. So I'm depending on you guys to get us there. Okay. Hey, Amanda, welcome. Okay, here we go.
These days in the culture, but my best guess is that probably 50% of our audience won't know exactly what 0 point energy is. So why don't we begin by defining it?
So 0 point energy is a strange phenomenon that was developed, the concept was developed in the early 20th century, first by Planck and then by the people who furthered quantum mechanics. And the idea is that, and it ultimately comes from the uncertainty principle, which says that you cannot measure two linked parameters to absolute precision at the same time. So for example, you can't measure the position and the velocity of a particle to absolute precision at the same time. So if the particle were standing completely still, then that would mean that you did know everything about it. The end result is that nothing can stand still. So everything wiggles. All stuff wiggles. Everything's got this ground state energy that wiggles. And not only does stuff wiggle, but space itself does too, in the sense that there are always electromagnetic oscillations, electromagnetic fluctuations that come in and out of existence throughout all space. And so this strange phenomenon has been the ground state in quantum mechanics, but it's generally considered to be a ground state that's just there. You can't really take away from it or give to it unless, except for a very short period of time, you just borrow and so on. It's just there.
You know, it reminds me of a thought that's been around esoteric literature for a long time, that the universe itself is alive.
Mm-hmm. Okay. I thought you were going to go in a different direction. So yes.
I like that. Guys, I agree. I think the universe is alive. I don't know. That's not the direction I would have taken that conversation, but I agree. I think the universe is alive, chat. No question. Okay, here we go.
It is conceptually that everything wiggles, everything is alive. I thought you were going to go into a discussion of the void and nothingness, and that everything emanates out of.
And that's a good question. There is no such thing as nothing as well. This is something where I think Terrence Howard is right about. There's actually a quote from Stephen Hawking that I'm probably going to try to post in the next few days or whatever, although I don't know. I always that he like kind of rails against creationism. I think he might have been wrong on that front, because we know the Big Bang comes from nothing. So if that's the case, then there must be a way for something to come from nothing. And I don't think that there is nothing. I think that it comes from something. And I think that the 0 point fluctuations are where all energy and matter come from. And it doesn't mean that there can't be still some constant amount. I mean, the universe is huge. It's basically infinite in size. So with respect to the our size relative to everything else, there is an infinite amount of energy out there.
Of nothingness. And that also ties in with 0 point energy in the vacuum.
Because things are constantly moving in and out of the void. Is that what you're saying?
Yes.
And so as an engineer, your interest is this energy. If we were to try and quantify it.
Yeah, the wiggling is the Zitterbuergong. I don't know how to spell it, but I'm going to be digging into the Zitterbuergong probably next week. I may be doing some posts on it as well. I'm not really sure. But that is something that I saw referenced in Hal Puthoff's paper, Unifying Gravity and ZPF, that's based on Sakharov. So, and that's like the wiggling that's going on, the Zitterbuergong. Seems very relevant.
it could add up
Oh, also, it's a really cool word.
to something quite significant.
It's a huge amount of energy that's there. If one does the calculation, it turns out to be absurdly high. In a cubic centimeter of volume, there's enough energy to boil all the oceans.
Whoa, what did we just hear right there? Booyah. I think it was Wheeler and Feynman. Am I correct on that? The first people that are attributed to that. You hear it all the time. Pudov mentions it all the time. This is something that if you guys are promoting this, you need to push it all the time. There's enough energy in just a very small area of space itself, of the 0 point energy, to boil all the Earth's oceans. So this is where the reason why that's important is that you understand how much huge amounts of energy are out there. We could dip into that energy and we're never going to make a difference. For our practical purposes, the amount of energy you use to power, I'm using right now to power 2 lights and my computer and everything I've got going on here is infinitesimally small. Infinitesimal. It's basically nothing to take to do that. And then we've got basically an infinite reservoir just in the space between my fingers here. There's enough energy to probably power, this whole city that I'm in right now. Crazy amounts.
But the question is, can you ever access it? Can you ever remove it?
And this, of course, has been the quest of inventors, I should imagine, for many generations. The idea of what would you call it? I know you have technical terms for it, but there are the notion that you can get something out of nothing. In effect, has always defied inventions up until now. I mean, maybe the atomic bomb is something of an example along those lines.
Really interesting. He drops the atomic bomb reference right there, chat, because you can see the connection right away. When you think about the atomic bomb, it seems like the explosive energy is coming out of nowhere, but really it's just E equals MC squared. So in my opinion, I couldn't be more certain that we first figured out this science from the Manhattan Project, because you have atomic bomb equals MC squared on one side and you have 0 point energy on the other side. It's like one is energy equals mass times the speed of light squared, which is a huge amount of energy. And the other side is, where does all energy come from? If you can tap into the source and we have E equals MC squared, this is where now you can amplify your nuclear weapons to infinity. This is where you can create a black hole. This is why I think you can create a black hole.
It has been around for a while, and it's been fodder for inventors and quacks.
Yeah.
And the problem is, often one speaks about...
Bruv, 0 point energy is for quacks, then just call me a quack. I'll take it. I'll take it all day long. I'd love to be in the company of Hal Pudov and Eric Davis and Sal Paez. If those are people who are quacks, then call me simp for the quacks, guys. Oh, also, I think I missed a donation. Dominate again. There's a new Captain Disillusion video. He basically confirms MH370 is undebunkable at 52 seconds. Watch the first. Really? Captain Disillusion. Guys, is this real? Okay, guys. Anybody who's watching, your responsibility, if you're in my Discord, find this video. Post that video, post that link in my Discord, guys. Holy crap, that's huge, chat. Holy crap. Thank you for the donation. Holy crap, chat. Wow. I mean, I know the videos are undebunkable, but there you go. That's crazy. Okay. We're not going to watch this whole thing. Don't worry.
Free energy systems. So that is systems which get energy indefinitely out of nowhere, and you just continue to obtain as much energy as you want. And at least all the physics that I'm aware of just does not agree with that. Energy must come from somewhere. It doesn't just exist. It just doesn't keep on coming from nowhere. And so I believe often this is a misunderstanding of 0 point energy. Even 0 point energy presumably has to come from somewhere, perhaps the space itself.
People might, if they have a religious orientation, say it comes from God.
Fair enough.
But in other words, we are not able to pinpoint the source other than to say, as you did earlier, the void.
Right. It exists. It's a fixture of nature.
And I know from our previous discussions that.
Okay, so we're gonna do we want to listen to harvesting principles? It's only 2 minutes. Let's listen to it.
In order to tap into this energy or to harvest it, one would need to apparently violate the second law of thermodynamics. So let's talk about that.
Okay, so
this is important. This is why I want to listen to this part. Yeah, I don't see the link to the video. So who is that? So Dom18, if you can give us a link, please give us a link, brother. Appreciate those donations. We definitely want to see that. I don't see it on his YouTube channel. Curious though. Okay, so we're going to listen to the extraction here in the second law of thermodynamics, because I've learned that we maybe don't have to violate the second law of thermodynamics. It could be more of a matter of how we think about the second law of thermodynamics. That's going to be the problem. So let's see what he says.
So the second law of thermodynamics has a lot of different variations in how it's described. But one way of looking at it is that you can't have a system that's at a uniform temperature, so say ambient space all around us, and continuously extract energy from that. You need a temperature difference to drive the energy flow.
Interesting.
And if, in fact, with 0 point energy, you're extracting it from the thermal background, from just ambient space, then yes, it would violate the second law. But it's not clear that that's where 0 point energy is coming from. In fact, there's been some recent work just in the last, actually a little more than a decade, theoretically, and in the last few months experimentally, that discusses quantum energy transport. So according to this, just as one can transport information, say in a quantum computer.
This is really interesting because this connects the idea of quantum teleportation to extracting energy from the vacuum. And I think it was Hotta, H-O-T-T-A, that was in early 2000s, 2008 maybe, that mentioned this. Because if you look up quantum teleportation, I think that there's a paper that comes up about this, or not a paper, but an article. Hey, Barry, welcome, brother.
From one place to another through nothingness, one can transport energy via the same mechanism. And if you can do this, that means that when we're extracting 0 point energy from one location, it's actually being transported in from somewhere else. So you're not violating any law. So it's just unknown.
So it is that simple.
You're talking about what people have called the quantum leap, where a particle, an electron, might move.
Nobody calls it the quantum leap, guys. That was a TV show.
From one orbit to another orbit without passing through the intervening space?
It is related to that, yes. It's tunneling, which is essentially a quantum mechanical tunneling is, as you say, getting from one place to another without ever having been in between.
And so this is
so the answer is, so what he just said there is huge, and I think that MF Luter just kind of listed it, is because you have to think of, like, when people say you're violating the second law, the first thing you should say in response is, what do you think the second law of thermodynamics is? A lot of people don't even know what the laws of thermodynamics are. They've just been told that you can't violate them, but they don't know what they actually are. So what he said there was, if you take an area, you have uniform heat temperature, you can't achieve over unity because you're always going to lose some energy due to the mechanical processes of extracting the energy. But in this case, we're not extracting that heat energy. We're getting the energy from somewhere else outside of our system, in an open system. So we're not looking at our closed system anymore. The energy is coming from up here, out here, or over here, wherever, somewhere outside of this system. And this is also the way around the first law of thermodynamics. The energy can't be created or destroyed. That's fine. We're borrowing it from somewhere else. So when you look at it from that lens, a different lens, then we're not violating the first or second laws anymore. That's really important. So now I'm not going to have to say that we're violating the laws of thermodynamics.
A well-established principle.
But this is why I say we have to at least reimagine the laws of thermodynamics, because traditionally you had to say, okay, well, then we have to redefine it a little bit, right?
Quantum physics.
Yes, it is.
So what you're suggesting, and if I understand it correctly, you've built many, many devices that are able to, at least at a very small scale, harvest energy in this fashion.
My lab has been building quantum tunneling devices for decades, just not for 0-point energy.
Okay, and that's a good, so look at this right here. You can see this is his upper electrode. So it's a semiconductor, insulator, semiconductor. Quantum tunneling through an insulator, energy flow is balanced, therefore 0-point energy cannot be harvested. So I'm going to switch over because now he's talking about the idea of a Casimir cavity. Maybe we'll listen to this. We'll probably just, there's another video that we're going to watch here. We'll just skip past the parts we've already explained.
We've also, in our previous discussions leading up to this interview, talked about the importance of the Casimir cavity.
Full screen, sorry.
And I know this is central to your own interest in harvesting 0-point energy. So once again, we need to define it for our viewers.
Good. So in 1948, Hendrik Casimir thought of a story about how they went for a walk together, where all the time. If you have two closely spaced mirrors, then those mirrors,
okay, I'm going to skip ahead.
What's happening in a Casimir cavity is you've got a restricted number of wavelengths. Outside, you've got all the wavelengths. This is just the same
thing. Okay, I'm switching over to the other video. Where is the other video? Oh, I have it. I forgot. This is where I have it pulled up here. I downloaded it so we don't get stuck. Problem now is I don't know where the breaking points are.
I'd like to tell you about a scientific journey that my lab and I have been on for the last couple of years in developing.
We're going to skip through some of this as well. This is called Unlocking 0-Point Energy by Moddel. Unlocking 0-Point Energy. It was posted on August 1st, 2021, 3 years ago. Okay. So that's what we're looking at here. If you want to see it yourself, I'm going to skip through the intro. I'm going to skip through the background electromagnetic fields. We're going to start about 10 minutes into this. So let's go about here. Here we go, right here. This is where we're going to start.
Point energy are very short-lived. They're extremely short-lived. So how do we get around this? Can we modify the ground state so that it's not uniform everywhere? Well, it turns out that for 0-point energy, you actually can. And that is that the vacuum state depends upon the structure around it. In other words, it's geometry dependent. So this would be as if you could have an ocean with a flat level, and then one region of the ocean would just have a dent in it, a well in it.
So I love this example that he gives right here, because you can imagine space-time. And you imagine just sucking out an area of space-time. You suck out the area of space-time, and now you're going to move that somewhere else. It's kind of what he's explaining right here, guys. Oh, if that was your birthday, Jessica, happy birthday 2 days ago. Sorry we missed it. Happy belated birthday.
It was lower than everywhere else.
Oddly enough, played the wrong video
you can do this, and it's been demonstrated.
Oh, and so the other thing too is that Michael Strat says is right when you can detect certain types of free energy devices. Yeah, they can detect them. The reason why they can detect them is because they are producing gravity effects. And if you have a high frequency gravitational wave generator, you can detect any type of gravity wave that's being produced even at a very small scale. This is why they can find them. I'm almost 100% sure Antarctica has a high frequency gravitational wave generator as well.
With a 0-point energy. The way has to do with a structure called a Casimir cavity. So in 1948, the physicist Casimir was doing some mathematical analysis on having two closely spaced mirrors. And he said, if...
Okay, I know this is somewhat repetitious, but in about 2 minutes, he's going to get to the engineering of the Casimir cavity that he's done. By the way, he has a patent Garrett Moddel has a patent for this that's been out there since like 2005. So he's been working on this extraction of energy from the vacuum for a long time. He's not a newbie to this.
There are two closely spaced mirrors. That means that you'll only be able to have a certain number of modes of wavelengths within this closely spaced Casimir cavity, but outside you could have all sorts of wavelengths. So this is, think about it like a guitar. So a guitar string.
Yes, this is also the reason why these crafts can float through the water. Here's something else. This is like in the middle of the stream, but I want to drop this, which is how can these crafts be transmedium? Because they are just flowing straight through solid matter. They are just going straight through it. Remember in Salvatore Paez's the interview with him, I asked him, can you go through solid matter with this? And he got real sus about it. Well, because when you're at this level where you're like manipulating gravity and space-time itself, you're just bending everything around you. You're like making a bubble in space-time. So everything else is like apart, but it's not really getting pushed apart. There's a smoke ring example that I'm going to probably show with Stan Deo, where it looks like when you do this type of effect, like you just go straight through the smoke and nothing is disturbed. This is the reason why in the video, why do the clouds not blow away? Why do the clouds not get sucked in or blow away? Because this is a gravitational effect that we're seeing, a manipulation of the engineering of space-time itself. And when you do that, there is no shock wave. That's not how that works. You just literally are tunneling right through solid matter. Or in the case of gas, it doesn't matter what it is. It can be gas, it can be water, it can be maybe even solid. Because when you boil it right down and you get to the subatomic level, most stuff is 99% free space. It just looks like we're solid. But if you were to go to the atomic level, you're going to see mostly emptiness. And that's the level gravity is working on, the Zitterbuergang. Neat, huh?
Is pegged on both ends, and therefore it just vibrates.
By the way, that's me pushing it as far as I could push it, chat. So hopefully you appreciated that.
At a fundamental frequency in its harmonics. Same thing with zero-point energy. Inside a Casimir cavity, all wavelengths that don't meet the appropriate boundary conditions are suppressed. Another way of looking at it is that it suppresses all long wavelengths. So any wavelength greater than twice the spacing of the cavity ends up being suppressed. And other wavelengths are permitted. So Casimir came up with this concept, and one of the predictions he made is that because there'd be more zero-point energy radiation outside the cavity than inside.
This is a good point on the smoke trails, but the effect that we're seeing happen on the plane is not necessarily the same effect that the orbs are happening as well. Two different effects that are closely related. So it doesn't necessarily mean that they wouldn't displace the smoke. It could still be that whatever the orbs are doing with their field around them is not exactly the same as the wormhole. But the wormhole itself, that's the reason why you're not seeing shock wave. That's why you're not seeing a black hole where you're seeing stuff get sucked in. Is it's fundamentally equivalent to just warping space itself, and then space is reverting back to its original form right after that. So at the end of the day, nothing has actually moved relative to where it was before. Pretty damn weird, honestly, but that's what quantum stuff is. Weird.
There'd be a radiation pressure that would push the cavity walls together, and these two plates would be pulled together. So he predicted this in 1948, and it wasn't for several decades, and really until the end of the 20th century, that it was measured accurately, and he was right. And so these Casimir cavities do in fact have plates that are attracted together. This only happens for very, very closely spaced plates, and it happens only, it's a fairly small force. So these plates need to be less than a micron apart, a millionth of a meter, and the force is tiny. Okay, so we now say that yes, we can modify the ground state.
Okay, so one person says, Casimir effects act at such a small distance they can't move an airplane. Well, we just talked about how to engineer them to make them increase significantly. The closer the plates get, the more powerful the effect. So then it simply becomes a matter of how you engineer it to amplify the effect. Again, this is how all stuff works, guys. Like, The moment you've proven something is possible, an effect is possible, then the question is, how do you engineer it to its full potential? I know for sure that it can be amplified up. So if you're the type of person that says, "Oh, it's too small. There's nothing we can possibly do that." That's the same closed-minded mentality that people had when they said that voices can't transmit through wires, that telephones are not possible. Like literally, there's direct quotes saying that like only crazy people, and I'm paraphrasing, only crazy people think that voices could be transmitted through wires. We don't even need wires. We don't even need wires to transmit voice. They just happen now. So if you're sitting out there thinking, oh, well, the Casimir effect's cool, but you can't possibly do anything with it, you are literally the same type of brain dead idiot who thought that we couldn't transmit voice through wires. I just want to put that in perspective for you. 100%, this will allow us to create a wormhole. I mean, generally speaking.
But then we have the problem of equilibrium and the violation of the second law in trying to harvest zero-point energy. So is there some way around it? Is there something we can do to get around it? Well, by answering the third.
The orbs are not necessarily made of Casimir. It's not a material that they're made of. That's not how it is. What we're trying to do is we're trying to get the effect. The effect is a negative energy pressure differential effect. So if we can create this effect using some type of superconducting mechanism, superconductor is a movement of electrons freely, a macroscopic quantum effect, then perhaps we can make a bubble. All we need to be able to do is make a bubble. And if that bubble is of negative energy, then what's going to happen? It's going to get shot off somewhere. The way I imagine is you make an extremely thin soap bubble that has its own eddy currents of a superconducting effect. And you create inside of that a Casimir void. Or maybe you create a shell where you have two thin layer bubbles. And then you have a very, very, very tiny area between them that creates your Casimir effect. That could be another way to potentially pull it off. Not entirely sure, because I don't know how to exactly engineer a wormhole. But that's what I'm imagining here. But it's not a situation where it's a hard material, because with the orbs, what we see is they're creating a field, electromagnetic field. Now, what did Hal Puthoff say early on in the beginning of this stream? He said, if you remove the electromagnetic 0-point fluctuations, what will happen? You will get pushed, because the fluctuations behind will push you forward. So this is where you want to think of the turkey baster, okay? I wish I had a turkey baster. Maybe I'll get one for my parents. You have your turkey baster. You squeeze the turkey baster. The water shoots out. The turkey juice shoots out. The air shoots out. Same idea as the plane. Instantaneous transmission, teleportation, wormhole.
Third objection, maybe we'll find a way. So that has to do with extremely short-lived fluctuations. So before I go there, I want to tell you about...
and real quick, shout out to JK Philly Fan. JK Philly Fan is he's been on this journey with me since like the beginning. I think JK Philly Fan got involved like a month into the investigation back in like September of last year. And I think out of everybody out there, not including the people that already understood a lot of this, he probably understands it even more than I do to some cases, but he is like way up there as well in terms of like going from where we were before to like where we are now. JK Philly Fan and I have gone through like transformation. So good work, JK Philly Fan. Appreciate you, brother.
Equilibrium and detail balance. So equilibrium means that everything is in harmony and there's no net motion anywhere. But there can be motion, and there can be particles and energy moving. So for example, if we have a system that has 3 parts, here I'm labeling them A, B, and C, there can be energy flow from A to B, but there is a detailed balance in which the energy flow from A to B is exactly balanced by the energy flow from B to A, and the same thing between all the other parts of this system in equilibrium. And if this weren't true, what would happen? If it weren't true, then we might have a net flow. For example, if 0-point energy everywhere were absorbed by a leaf, and a leaf is a nonlinear material, And so the leaf is going to take these 0-point energy fluctuations and down convert it into heat. And so we'd see hot spots all over the place on leaves and every other sort of nonlinear material within our universe. But we don't. Why do we not? Because there's a detail balance. In other words, whatever might be producing heat, the reaction also goes in the other direction, and we don't. Can we break that detail balance? And so here we come back to these extremely short-lived fluctuations. So this gets into the notion of, again, the uncertainty principle, but the delta E, delta T, that is uncertainty in energy and uncertainty in time. And there has been proposed by a physicist, Larry Ford, that there's a quantum inequality. And the quantum inequality says that an energy, delta E, may be borrowed from the quantum vacuum for a time, delta T. Then it has to be repaid, and it has to be repaid with interest. So how long can you borrow the energy and how much energy? Well, if it obeys the uncertainty principle, and it's not clear it does exactly, but
so this is really interesting because the idea here is there a way around borrowing the energy? And the way is actually pretty straightforward. We're borrowing it from the source. So technically we are extracting that energy and we're not really giving it back, but it's so infinitesimally small that there's no negative consequence.
But if it does, that would mean we could borrow, say, a photon, a red light photon's worth of energy for a tenth of a femtosecond. Now, femtosecond is extremely small. It's a 0.
He's about to get to the good stuff.
15 zeros, 1/6. It's an extremely short time. But during that time, we can violate the first law of thermodynamics.
Okay, that was really interesting. We said is that they're there for a femtosecond. Why is that important, guys? Why is femtosecond so important? Well, how about because somebody just won a Nobel Prize last year for coming up with an attosecond laser, which is 10 to the minus 18. Because if we can make a laser that's faster than how quick we need to be to extract the energy from the vacuum, then perhaps that's our mechanism for being able to pull photons, pull energy directly from the vacuum and not give it back. Because we can go faster than how long those virtual particles have fluctuated into existence. Very interesting. And maybe that's the secret too, to how fast we have to spin our mirrors or our dynamic Casimir effect in order to extract the energy. Here's the paper that the piece I was talking about earlier. Jessica pulled it out. Scientists use quantum mechanics to pull energy out of nothing. This is the one that mentions quantum teleportation as well. So take a look at that one if you guys want. Like all of this science is pretty much new too. Notice the dates on some of this, like 2023. Remember, the MH370 videos were made in 2014. Most of this science didn't exist back then. Traversable wormholes didn't exist back then either. So whoever made those videos knew more about the science than people even do now in 2024, at least laymen.
That is, we can actually get energy out of nothing and we can see it, but then it's got to be returned.
Yeah, I feel bad that a lot of people come from Danny Jones because that was one of the worst podcasts that I was on. Like Danny Jones literally was trying to debunk me, which was just super shitty of him in general, especially because he didn't like tell me ahead of time. But I do get a lot of people that come from Danny Jones because he's very popular out there. So if you did come from him, what I first would recommend was check out the Redacted podcast with Clayton Morris. That will get you much more up to speed. Now, if you want to know more about the science, like I've come a super long way. So I did Danny Jones before I knew anything about any of the science. That was back in October or early November. And I knew nothing about the science. So if you want to know more about the science, check out my most recent interview with Jim Peters. I just posted it today. That one goes way more into the science of all of this as well. Or you can check out the one I did with Mike Adams, the health ranger. That's another good one if you want to dig into the science.
Okay. Well, if we can borrow it, could we be sneaky and could we borrow it and capture it very quickly? And if we could borrow it and capture it very quickly, then could we skirt detailed balance. And this was what I was thinking about as I was trying to come up with a way to harvest 0-point energy. And the way that I thought we should try involves metal insulator metal diode. So let's talk about that.
Metal insulator diodes. So he literally is just describing the exact same thing that the dynamic Casimir effect used. Casimir effect also used semiconductor, insulator, semiconductor. Interesting.
If you have a metal insulator metal diode, so you've got a piece of metal, a very thin insulator, and this is going to be a couple of...
And one, I'm just going to, Jackie, I want to address Jackie for a second because I've seen Jackie spamming my my YouTube comments with like 10 comments each. I get the impression that Jackie is relatively smart when it comes to mainstream physics. Unfortunately, when it comes to understanding 0-point energy, you're essentially the equivalent of a 5-year-old. We are not accelerating the plane. The fact that you don't even understand that we're not accelerating the object itself shows that you don't even understand the fundamentals of what we're discussing. We're talking about engineering the vacuum itself. So if you're confused about this, I suggest checking out what Einstein-Rosen bridge is, because it doesn't have to do with moving the specific object. All you need to do is engineer the vacuum, not the object, the vacuum. You need to be thinking about it correctly. This is the reason why all your questions are wrong, why all your interpretations are incorrect, is because you don't understand the fundamentals. And until you understand the fundamentals, you'll never be able to understand what we're talking about here. And I'm not trying to say that to be rude. It's just a fact of the situation. So you can keep commenting on my posts. I haven't removed any of your stuff. I haven't removed any of your comments. But I want you to understand why you're wrong so that you can hopefully try to look at the situation in the correct light. And then you'll see how this all ends up working out. If not, you know, you're welcome to sit out there and be a detractor too. I don't really care.
Nanometers thick. That means about 10 interatomic distances or so thick. And then another metal. You can excite electrons on one side, and those electrons.
So this is probably the most important part that we probably need to understand from this, because this is how he's creating the energy differential or the pressure differential. And I actually don't, I'm not sure I fully understand myself. So I'm going to rewind like about 30 seconds here. I want to listen to it again.
Insulator metal diode. So let's talk about that. If you have a metal insulator metal diode, so you've got a piece of metal, a very thin insulator, and this is going to be a couple of nanometers thick. That means about 10 interatomic distances or so thick. And then another metal. You can excite electrons on one side, and those electrons tunnel through this forbidden region of the barrier or the insulator.
Okay, I get it.
Get captured on the other side.
I get it. First of all, thank you to Matt. Appreciate it. Wherever you're at. I don't know where that donation's at, brother. There it is. So thank you very much on the Matt on that donation. So I just understood what it is now. This is how we're trapping them. We're exciting the electrons on one side, on this side, and then they're able to jump the gap through the insulator. They jump the gap through the insulator, and now they're trapped on the other side because they're no longer in their excited state. So therefore, they can't get back over to the other side. That's pretty cool. I love that idea.
And once they're captured on the other side, it's very unlikely that they'll be able to go back again. And so in this way, we might be able to very quickly capture 0-point energy, because this tunneling process takes place on, takes about a femtosecond or so to occur. And so we might be able to absorb some of that 0-point energy. So I thought, okay.
There's another good video we're going to look at related to the smoke ring thing, because it does help to understand this. Smoke rings are much weirder than I thought.
How are we going to do that? Well,
okay, here we go.
Let's take a look here at...
Okay, now it's getting spicy, chat. Here we go. Hope you're watching. This is really good. The vacuum works by unaccounted magic then, which you're not explaining. I literally explained it in my last stream. Go to the Wednesday stream, Jackie. It's called 0-point fluctuations as an explanation for gravity. Explained it. If you don't understand it after that, well, then you're on your own. But done a pretty good job of explaining it. Whether or not you can comprehend it is a different thing. The first thing you need to understand is space is not empty. we've been talking about here as well. So what happens if you make space truly empty? Think about it. Anyway, I've explained it more than enough. The reality of a lot of this, and this is what I've been told by the very smart people and contacts that I have, is that the reason why we haven't figured a lot of this out is because many people are so brainwashed by what they were taught and what they think is possible or not possible. They don't see the physics in the right light. Even very smart people don't see the physics correctly. And if you don't see the physics correctly, then you can never understand why it's possible. This is part of the reason why it's not a matter of getting the information out there. It's not a matter of saying, here's the device, because if people don't see the physics correctly, you can show them a working device and they will never believe it to be real because they don't understand how it's possible. Simple as that. So it's a matter of trying to change people's perceptions of reality, so to speak, away from the way that they were incorrectly taught in school that doesn't teach any of this, and change it so that they can see the way the fundamental fabric of reality really functions. 0 point fluctuations all around us all the time. Energy doesn't come from nowhere. Energy comes from the vacuum. The energy that we're seeing around us here is also not coming from the coal that's being burnt. It's coming from the fact that we've created an asymmetrical diode, and that is allowing energy to be extracted from the vacuum. All energy is a negative entropy effect.
The concept. So we've got a base metal, thin insulator, and an upper electrode. And this upper electrode is very thin. It's so thin that if a radiation, any sort of radiation, is absorbed, light is absorbed, it creates hot carriers. And these hot carriers, or hot charge carriers of electrons, then can travel through this thin upper metal electrode before they're absorbed, and then they can tunnel through or go over the barrier that's between the upper metal electrode and the lower metal electrode. Now, if this metal insulator metal diode is just sitting out in free space, there's also going to be the opposite current, because there will be internally generated hot electrons from the same sort of 0 point energy or whatever is producing it out here, and they'll cause a current to go the other direction, and there'll be no net flow of current. But what happens if we do something? Now what happens if we add to this a Casimir cavity? So we're adding to this a Casimir cavity on top, and we...
Okay, so this is interesting. So we've got our semiconductor, we've got our plate, and then we've got another conductor here. The electrons or what have you are being excited in the upper electrode, which allows them to jump the gap. And then you have a current because you have because now you have this gain of excess electrons. So as the buildup increases, they're going to start jumping back as well, is the way I understand this. And now we add a mirror at the top as well, which is just another perfectly conductive surface. I guess that could be a superconductor as well.
No, we just found out that a Casimir cavity reduces the allowed wavelengths in this Casimir cavity between these two mirrors, so that there's less energy here than there would have been in free space, because it restricts the vibrations on the guitar string, if you like. And so therefore, we're now going to have less radiation coming in. We'll reduce the current going this way, but perhaps the current going the other way will remain the same. And in that way, we might get a net flow of current from the base electrode to the upper electrode. So the actual device that we built is depicted here.
That's pretty interesting, man. That's really, really interesting. So the squeezing is happening because you've created your Casimir cavity. So certain wavelengths can't fit in there. So you're getting a net pressure differential towards the cavity. And I guess what he's saying there is then that what that increases, I want to listen to that one more time just to make sure I understood that correctly. Is that what he's saying when you look at this here then is that you're going to get some net current bouncing back. Net current meaning the big arrow minus the small arrow.
Wavelengths in this Casimir cavity between these two mirrors, so that there's less energy here than there would have been in free space, because it restricts the vibrations on the guitar string, if you like. And so therefore, we're now going to have less radiation coming in. We'll reduce the current going this way, but perhaps the current going the other way will remain the same. And in that way, we might get a net flow of current from the base electrode to the upper electrode. So the actual device that we built.
That's pretty spicy. That sounds like that could be producing infinite energy. Ashton is like the main dude in Foundation sci-fi that starts a colony. I have no idea what that means. Hari Seldon. I didn't see that, but sounds funny. Is Foundation a TV show? I don't know. Just the fact that we've already come this far, that we have we're looking at a possible way to extract unlimited energy with no moving parts, tells me there's something here, guys. It's only the year 2024. If you give Garrett Moddel here another 10 years, he's going to have it figured out and probably made it a lot more efficient as well. This is pretty awesome. This really, really excites me, guys.
Is depicted here. So this is our metal insulator metal device using nickel palladium, transparent dielectric. It's too hard to make this.
So let's see if we can understand this. We only have another 5 minutes of this presentation here, and then we'll probably call it for tonight after that. We got through a lot of this stuff. And there may be other ways to engineer it too. This is just one way to use a Casimir cavity. Basically, Garrett Moddel has figured out a way to break the magic card deck. He said, okay, well, we're not going to use 2 plates. We're going to figure out another way to engineer this, use it at a very small scale. Because if you look at this as well, how big does this have to be? This could be tiny. Could we make a microchip out of this? I think we could. The insulator here, I think he's talking about being 1 atomic layer thick. So we're talking about a device that's going to be as big as my fingernail or smaller.
Out of vacuum. So we use either a polymer or a glass as our transparent material.
Oh, the cavity itself doesn't need to be air. The cavity itself can be a metamaterial. Oh. What if we use one of those materials that was like the ones that causes optical phase conjugation? What if we use one of those materials here? Well, that's just an idea I just had off the top of my head. You guys remember the video about, thank you for not pandering. Guys, I don't do engagement farming and pandering or any bullshit like that at all. I don't at all. I also don't care about how much money I make on YouTube or Twitter or any of that shit either. It makes no difference to me. The only reason why I try to increase my production quality is because I want it to look nice for you guys. That's it. Anyway, I've literally been thinking about stopping streaming as well because I've learned way too much and I hate when I have to not say exactly what I think and what I feel. But anyway, there you go. This is interesting. So you guys remember the video? I wonder if I still have it. I kind of want to post it because I want to know what that was. Optical phase. Shit, I don't know. It's called optical phase conjugation. But in the optical phase conjugation video, maybe it's called phase conjugation. I don't know what the file name is. Oh yeah, here we go. I think it's this one. Yeah, here we go. I don't know if this is going to make a difference, but what if the material that was used in the cavity was the material they use here? What would that do? So they cover it up with a lens, right? And then ordinary mirror, nothing happens. Now I'm starting to see why optical phase conjugation, it is. Crystal BATiO3. That's what I wanted to know. BATiO3. Look at what BATiO3 does to this experiment here. So they covered that up with a shot glass. The image goes away. The image is now not backwards anymore. It's just correct now. This is a phase conjugate, like type of, I don't know if it's a metamaterial or what you call it. It's got some kind of weird refractive index or something like that. Now watch what happens when they cover it up with the shot glass. He's covering it up with the shot glass. It's covered up right now with the shot glass. There's nothing there. Wait for it. Time is going by. You can imagine the beams of light bouncing through the shot glass. What the hell? The image just appeared. Phase conjugation. This is optical phase conjugation. What you just saw right there with whatever this material is, BATIO3, just now allows, it takes like, how long did that take? Almost 20 seconds. And then all of a sudden the image just appears. Even with the shot glass covering it up. The shot glass is not even like a perfect cylinder or anything. The image just appears. What if we use that
then
in this? What if that's what was in the optical cavity? What would that do? Chat, I kind of want to engineer some crazy shit now, chat. If somebody knows if I'm even on the right. Oh, Ryan probably fucking knows. Ryan knows, guys. The martini's kicking in, guys. My swearing's increasing. I want Ryan to tell me what would happen. Numerous UFO narratives say that barium is commonly used in the craft. Yeah, right? Yeah, okay. You guys are starting to see the whoa, right? You guys are starting to get it. Yeah, I'm glad you guys are starting to get it. Okay, good. Yeah, the barium titanate. Now I'm sitting here wondering, yeah, the fuck. I should probably post that optical phase conjugation video again. It's the weirdest shit ever. Because one of the things that Dave Rossi taught us was phase conjugation is very important. And even Terrence Howard talks about phase conjugation. But what is phase conjugation? Why is it so important? The optical phase conjugation is very interesting because it seems like there wouldn't be a connection to like holograms, but for some reason, optical phase conjugation is used in holograms. And holograms have a connection to teleportation and all this stuff we're talking about. And they use like the same experimental setups. Like you look at the schematics of the experimental setups and they're like identical. And so there's some kind of connection here.
Loaded with a mirror. And in this way, we're making our devices, and our measurement circuit probes current flowing between the base electrode and the upper electrode.
Phase conjugate gravitation beam is a thing in Star Trek. Guys, Star Trek is apparently just a documentary. So if it was in Star Trek, we should probably just read it like it's a manual guide at this point. Like, I'm not even fucking kidding anymore. Like, imagine, I wonder if that's the secret here. I wonder if you put a phase conjugate type transparent thing in here, if that's going to make this thing just blast off to the next level.
This is a scanning electron microscope image of our device. They're very small. They're about 1/10 of a micron on one side and a little over 2/10 of a micron on the other side.
Oh, and no offense to Terrence Howard, but we are way beyond Terrence Howard when it comes to quantum mechanics. Way beyond him. I think he's a pretty smart guy. I think he's got 50% of the stuff right. 50% of the stuff he went too far in the woo. But we're way, way beyond him at this point. No offense to him.
So this was the concept I came up with. And I was working on.
So convexing the lens isn't quite the same. Like phase conjugation is fucking weird. Phase conjugation, instead of convexing the lens, phase conjugation is like if you look in a phase conjugate mirror, no matter where you look in the mirror, all you see is your eyeballs. It's a perfect bounce reflection directly back at the source. So therefore, no matter what you look at, even if you're trying to look at your feet, you're only going to see your eyeballs. That's why it's super weird. That's why I wonder, like, what if you just like, because it's like what I imagine, like breaking the magic card deck. It's like, what if you put something that breaks the system in here into this thing that we've got going on? Very weird. Holograms, I don't know about holograms moving, but holograms are neat because holograms take a 2-dimensional picture and they turn it into a 3-dimensional environment. It's a higher order effect, second order effect. Barium titanates ceramics show an aging effect during which the dielectric constant and the electromagnetical coupling factor decrease while the elastic contact in Q increase. I don't know what that means, but that sounds awesome. That sounds really cool. Yo, you guys noticed that Ryan went real quiet, chat. Ryan went real quiet. Oh, we missed it. We want to know if this barium titanate's going to break this thing. Tell us the truth, Ryan. We know you know the truth. Also, dude, Project Bluebeam is definitely going to come and they're going to pull some bullshit alien thing. I guarantee you guys at this point. I guarantee you. Sorry, I'm way behind on the message. You guys are spamming the chat. I'm trying to catch up. Ryan. Oh, well, let's just listen.
For quite a while. And my lab tried it furtively. We were doing other projects, so we really couldn't spend a lot of time with this. And it looked like maybe it was working, but it really wasn't very convincing. And finally, my technician, who's been with me for now about 3 decades, Dave Dorosky, and he said, look, Garrett, you really have got to give this a good try. Let's dig in and really do it right. And so he and a great postdoc in my lab, Ayendra Wirakoti, worked together and tried this. And they tried it with a number of different devices, and they tried it with a number of different configurations. And lo and behold, it actually seems to work.
Let's go.
So we actually got power from the vacuum. So let me show you the way that we measure this. And this—
Do the Tootsie Roll. Do the Tootsie Roll, chat. That's what I wanted to hear. Actually extracts energy from the vacuum. Let's go. Let's go.
This is,
okay, let's try to understand some graphs, chat. I'm not good with the graphs, but we're going to try.
Measuring the current as a function of voltage. So this is the current and this is the voltage. And we're getting out—
Chat, teach me current and voltage real quick. Which one? Is this good? Is this good, chat? What does this mean? What does this mean, chat? Presumably one of these quadrants is good. I don't know, maybe the top right one or the top left one? I don't know what this means. Chat, tell me which quadrant is good, chat.
About, in this case, about 75 nanoamps, and it's at a voltage of a few tenths of a millivolt, or almost a tenth of a millivolt. And the way that we can tell that we're getting power is this is the sort of current voltage measurement that's also done for solar cells. And there are 4 quadrants in the curve. So if your curve falls in this quadrant, as in up here, you're using power.
Oh, here we go. Here we go. There it is right there. Side note, guys. Got it. We got to make a side quest. Hold on. Hold on. Wait for it. Oh, shit. Wait for it. Wait for it. We're doing that Tootsie Roll, chat.
All in this quadrant, the second quadrant or the fourth quadrant, then you're actually producing power, and this one is using power. And in fact, our devices put out about 70 watts per square meter, which is actually not bad for little test devices. That's close to what a solar cell puts out, which is perhaps 200 watts per square meter. And we then did this for different cavity thicknesses. Now, you know that the thinner the cavity is, the more modes it suppresses, because the thinner the cavity is, the more it suppresses all wavelengths that are longer than the cavity, than twice the cavity width. And so we're suppressing more and more wavelengths as we make narrower cavities.
Interesting. So we can add, so now you're starting to see the real magic here, right? Is that we can engineer it to a point where it's like, how much do we squeeze the cavity? So if the cavity's thickness now, this is a graph of the cavity's thickness. Oh, and they're using different materials here, I think. So this is silicon oxide, right? Whatever PMMA is. Oh, so what if we use our barium titanate? I wonder what that would do. Too bad he never figured that out. I would love to see, hey, use the weird fucking barium titanate shit in here. And then what does that do? I want to know how that manipulates it.
And that's just what we saw.
What if barium titanate just like makes the energy go up? That would be crazy.
As we made narrower cavities, either from the polymer or from the SiO2, we found that the narrower cavities gave us more current. So you say, well, maybe this is just some sort of electrochemical reaction, or there's some sort of a degradation mechanism that's just producing the current. It's like a little battery. So if you calculate that we have how many atoms we have in the insulator, it turns out that if one charge were trapped at every insulator molecule, the current we're seeing, 20 nanoamps, would take about 3.2 microseconds for it to deplete. But we see this current continuously. Here's a plot showing the current as a function of hours. And actually, we've done this for longer times. The current comes out and it just keeps coming out. Then as another sanity check, we
4 hours
to see, for example, does it scale with area? So this was a different set of devices, and we made.
So basically, he's just checking to make sure, like, is it really working, or are they seeing some kind of weird artifact
up to about 100 microns? And yes, the current does scale with area. And we ended up taking more time in trying to disprove ourselves than we initially took to build these devices, simply because the result is so unbelievable. And we went through 8 magnetic pickup that we're picking.
Okay, testing for experimental artifacts.
Comes to about, and
basically, we already know it's not experimental artifacts. Like, the moment you know how the ether works, like, you don't give a shit about the experimental artifacts. We already know it can work. I don't need convincing that it's not some artifact. This is for what Jackie O's or whatever in the chat. That's what this part's for. We don't care about that. We want to get to the good stuff. It's not coming from solar neutrinos or temperature differences or whatever bullshit people are trying to come up with. Okay, here's the applications. So squeeze this. Oh yeah, okay. This is the part that I wanted to get to. There we go.
Are respected.
This is my favorite part of the whole video. Get ready.
And so what has the response of the scientific community been? What are they saying?
This video is 3 years old, chat. 3-year-old video. And he just showed experimentally this Casimir cavity experiment that he has a patent for. Patents out there. There's a scientific paper. I'm going to show you the scientific paper before we log off for tonight. Shows it's producing energy. They did all these tests to show that it's not an artifact. This is just literally extracting energy from the vacuum. What does the scientific community think, guys? What do you guys think the scientific community thinks is going to say? You nailed it. Oh, oops.
Given that this potential for something really radical has been described. None. There's been essentially total benign neglect. We've heard nothing from them.
So there you go, chat. Nada, zero, nothing from the scientific community. You can show them an evidence, an experiment that's done scientifically. It's got a patent. It's got scientific paper. He's got a hour-long video here explaining how it works. What does the scientific community do? Ignores it completely. Ignores it completely. Even explains how it's possible. It doesn't matter. So when people come at me and say, all you have to do is show it to me and people will believe it, I say, fuck you. Fuck you. You know how many times people have tried to show people and they just get ignored? This is a PhD professor who works in quantum mechanics at University of Colorado, who's used a Casimir cavity with a literal experiment using semiconductors to show that he's actually producing energy, excess net energy. Community doesn't give a shit about it. Hasn't looked at it for 3 years. Won't even look at his work. This is why academia is fucked. Mainstream scientists and physicists are absolute morons. We've achieved the level of idiocracy where we are too stupid for free energy and for any type of advanced physics. We just are stuck in this box where no one will look outside of it. And unless the media tells somebody that something's possible, no one pays any attention. Simple as that. That's why people ask me, why haven't you showed a video of your free energy device? Well, here's Exhibit A. Because my man right here has all the credentials in the world. He's got the experiment lined up. Anybody can watch this and look at it themselves. Who pays attention? Do you see Neil deGrasse Tyson reviewing this? Do you see Sabrine Hassenfelder reviewing this? No, none of them are. And even if they did, they would just look at it and go, yeah, well, it needs more experimental recreations and blah, 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 blah. It's like, God damn it. We are so fucking stupid.
And, you know, in the meantime, my lab has published other papers. We published another paper on something a lot less important in a journal, what is it, Nature Communications. We got all sorts of press coverage, interviews, and so on. But for this, nothing. Why?
You hear that? For his other stuff, he gets tons of press, tons of interviews. For this, nothing. Maybe I should reach out to Garrett Moddel and get him on Hard Truths. What do you guys think? Should we get Garrett Moddel on Hard Truths, talk about free energy with my man here? I'm going to probably email him later tonight. I'm going to write it down just so I don't forget. I got to go eat after this. Oh, man. It's crazy how powerful brainwashing is. And brainwashing is really what this comes down to. We've been brainwashed into thinking this is not possible. This is how they've been able to keep it secret from us. And then somebody comes up with something and they just go, well, I've been brainwashed to think it's not possible, so I'm not even going to look at it. Not even going to look. This is why when I show people the MH370 videos, they have this knee-jerk reflexive action because they've been brainwashed into thinking stuff like that's not possible. So it's literally their programming that's preventing them from even looking with their eyes.
I suppose people just don't know what to make of it. They just don't believe it. So
exactly. He just explained. They just don't believe it. Does this sound familiar? This is exactly what we deal with the MH370 videos. We've got more evidence than any murder case in the history of man. We've got, basically proof that the official story is a lie. We know 100% the United States government knows what happened to the plane, and it doesn't matter because people just don't believe it. They just don't believe it. And the fact that you don't believe it means it doesn't matter how much evidence there is for something being real. If they don't believe it, they have basically zero evidence that it's fake, mountain of evidence that it's real. Doesn't matter. They're not going to believe it. It's not a situation of informing people. It's the human condition that is the problem.
We really have met with some scientific challenges. So the challenge, that we talked about first is the second law of thermodynamics. So the second law.
Okay. So I think that's it for that. Because then he starts talking about the same stuff that we talked about before. We get around the first law and the second law of thermodynamics. How? Because we have this source that is not being incorporated into the law of thermodynamics right now. And if we can extract energy from that source, we're not violating the first law of thermodynamics. Energy is not being created. We're borrowing that energy from an existing source. From the second law of thermodynamics, we're opening our system up to outside of our box. We've got our closed system here. And we open our system up and say, oh, well, we have this other location where we can get energy from. That means that we're not actually violating the second law of thermodynamics. So welcome to Costco. I love you. It really is. We literally do live in idiocracy. Like, we are in idiocracy. We are in it. Emperor has no clothes. That's another one I think about all the time, is that, like, you're just brainwashed into thinking that the emperor has clothes, but the emperor literally is naked sitting out there. And all we have to do is wake people up. It's crazy. So Yahtzee as well. That's also another way to say the emperor has no clothes. I appreciate it, guys. Also, shout out to Michael Boyd as well. I saw him in the chat up here somewhere. I don't know where he's at. Shout out to you, man. I do think that you're on it as well. I'm not pretending to be an expert on all of this stuff. The reason why I push back on the idea of gravity shielding, this is as far as I'll push it. What I'll say is, we shouldn't think of it as anti-gravity, although you could argue that it is anti-gravitational effect because it counters the force of gravity. We want to think of it as gravity manipulation or gravity modulation. And the reason for that is because we're manipulating the vacuum. And what that's doing is causing a gravitational effect that counteracts the gravity that you would normally be feeling. It can also lead to inertial mass reduction. Your mass reaches zero locally, and you're not going to feel any gravitational effects as well. If this is still controversial, read the last few paragraphs of Hal Puthoff's 1989 paper on gravity as a 0-point fluctuation source, or explained as that. If you still don't understand it after the last few paragraphs of that paper, then we can talk about it offline. But I think that's really what helps to get the right mindset for it. That's as far as I can say. Okay. I forgot what else I was going to say, guys. Sorry, let me just take a look at any last questions before we log off for tonight. Yeah, show the patents. Patents don't mean anything. Literally, we had somebody say this. We say, here's the patents for it. And they go, patents don't mean it has to work. And then somebody literally links to Electroboom, Medi, links directly to them. Patents must work. Like, people are just brainwashed. They're just brainwashed. Like Medi Sal Latazar, whatever his name is, Electroboom guy, 7.5 million subscribers on YouTube. Doesn't know how energy works. Doesn't know how energy works. Like, you can't make this shit up. Thinks that just because a patent exists that it doesn't have to work. Proves that it does have to work. Goalposts move again. Like, this is how the craziness is, right? It's my science influencer doesn't think it's real, so therefore it's wrong. Show a working device. Oh, it's an old video. Literally, people said that. I showed people a working over Unity device magnetic motor. What was their response? Oh, well, it's 14 years old. What? That's your response? I showed meters. There's meters showing coefficient of performance of greater than 2. Doesn't matter. There must be cheating somehow. Like, even if you show people in person, they're going to not believe it. This is why I've had probably a dozen people message me, DM me, whatever, text message me, say, let me see this NDA, or I'll sign the NDA, show me the device. It doesn't matter. If you're somebody that believes that it's possible, me showing it to you isn't going to move the needle, because you come out and you say, I reviewed Ashton's device and it works. People are just going to say, so what? You know, Ashton, you're a liar, blah, blah, blah. Like, you've got to really look at it from the perspective of disinformation. The people that I need to convince are the people that have 7.5 million subscribers who don't know how energy works, who think that free energy is not possible. Those are the people, like the Medi Sal Latazars, whatever his last name is, Electroboom guy. Those are the people that I want to sign the NDA. Those are the people that if I can show them that they're wrong, that they don't know how energy works, just like Veritasium did when he showed him that energy isn't flowing through wires, then he can come out and say, hey, I'm an idiot. There might be a way to produce free energy. If he does that, that will change. That will move the needle. That will move the needle. Somebody who already knows free energy is possible, reviewing the device, isn't going to do anything. They're going to immediately come out and say, you are a plant, you're a liar, whatever, you're a crack, you're a crankpot. This is the part where, like, people need to incorporate the fact of the disinformation into all of this and the suppression, like with Garrett Moddel. Why is the media not knocking on his door to review his Casimir Cavity device? Because they're told not to. So suppression isn't just about lying. It's about ignoring information that's real, not letting the media report on it. The same way that the media has talked to this kid in Vegas who saw aliens in his backyard. Like every single media station talked to this kid. Nobody will talk to me about the MH370 videos. Why? Because I would convince people that they're real. They can't have that. You can't have that. So there you go, guys. Okay, I'm probably going to reach out to Garrett Moddel and try to talk to him, guys. I also think that Professor David Greer, he's got this this tractor beam. I think that whatever he's got with his tractor beam is probably very similar concept. So the last thing I want to say for tonight, guys, is all this technology is irrefutably linked together. If you're wondering, why is Ashton talking about free energy? It's because free energy is tied to gravity manipulation technology, which is then tied to space-time manipulation. So if we can so the benefit of this is that even if we show that EM drive, the ability to just have an electromagnetic drive that has no propellant, if that's possible, everything else is possible. Free energy is possible. Warp drives are possible. Wormholes are possible. All of it becomes possible. And this is where I always said this for almost a year. It's a Pandora's box. The moment that box is open, everything is coming out. This is why they have to suppress every aspect of it. They also have to suppress LK99 as well. All these technologies must be suppressed. The moment any of these technologies come out, physicists are going to go, wait a minute. Wait, what? If this is real, does that mean that's real? And does that mean that's real? And then they're going to question, wait, does that mean everything I've been taught is a lie? And that's what can't be allowed to happen. We've reached a point where the lies have stacked up so high where like there's no easy way out. Somebody's going to have to take the fall for this. Somebody's going to have to take the blame for why we've been getting lied about physics and science for 100 years. And why the government's hiding. And the government's come out and say, well, we were hiding it for your best interest because this is a weapon of mass destruction. Okay, great. Well, there's going to be some people at the bottom as well who are going to have to take the fall for this. Shai Keenan, hello. Thank you for joining in late. Shai Keenan, big shout out to you. Shai Keenan was one of the first VFX experts that came out and said, man, these videos would be really hard to recreate. Where everybody else was going, that would be really easy. I could do that in my 2 hours in my free time. And then you go, okay, go ahead and do it. And they go, well, no, I'm not going to do that. It would be too expensive. I don't want to waste my time to do that. So anyway, thank you guys. Okay, guys, just looking for any last questions before we drop off. Which camera or webcam do you use? That's a brand new question. That is an Sony A6600. So one of the first things I did with my very first social media and YouTube money was I bought a nice camera. It was like $1,500 with the lens. I got like a default lens. But as you can tell, it looks really good. And I've loved using it for this last year that I've been streaming. If you are serious about streaming, you have to have a good camera. You have to. It just makes all the difference in the world. Makes your production quality so much better. The best thing you can do is get a decent camera. You don't need a lens that's got like, a million different settings. You just need one that's like whatever distance it's at, that's perfect, just like this is. So there you go. Good question on that. Yeah, and it is just a dumbing down of society, guys. So just as a review of what we talked about, we discussed the Casimir effect. Casimir effect is related to every single one of the technologies we've talked about: free energy, negative energy, warp drives, manipulation of extra dimensions, and wormholes. And we talked about the dynamic Casimir effect, which dynamic Casimir effect is really, really interesting. Producing photons out of nowhere. And then we looked at Casimir cavities, which I think that Garrett Moddel has done a great job, but I think that he can move it even further. I have a feeling, I just have a hunch. My intuition tells me that we can make it even better than that. And that potentially we can produce huge amounts of photons. And if we can produce huge amount of photons, that's gonna break people's minds for sure. That's a Nobel Prize for sure, guys. Okay, guys. Okay, I think we're gonna stop now. You guys have a great night. Thank you guys very much. I will talk to you guys on Monday. Monday, we're gonna go over the debris. We're gonna have a Malaysian Airlines Monday. I'll do a question and answer. I'll answer any questions on the MH370 case. We'll do an update on what's been going on with respect to that. And then we'll get back into science on Wednesday, guys. Have a great weekend. Love you guys, MH370X. Peace, guys. I'm going to play us out with a different song tonight, I think. Actually, no, I think we're going to play us out with the same song. think we'll do that. Oh, you know what? We're gonna go back to the Tootsie Roll. I'm gonna do a little Tootsie Roll dance, and then we'll get into that. Okay, here we go. Where is it?
To the left, to the left, to the right, to the right, to the...
Okay, I love you guys. Have a great night, everybody. Peace.
Out in the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
Thin shell formalism placed so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plates, creating the throat, open the gates, from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear.